Today we're going to discuss a topic that a lot of people have been talking about, which is, will AI agents replace software developers? So AI is no longer just autocomplete. Today we have AI coding agents. And the question people are asking is if AI coding agents can start rewriting perhaps your whole code base, perhaps a big chunk of your code base, what will happen to software engineers? Will they simply become managers of a bunch of AI agents, or will their job largely stay the same? So in a previous video, at the first half of 2025, we covered some AI trends, and I'll put a link in the description. But today, in the second half of 2025, using AI coding agents is starting to become popular, right? We have AI completion and code generation, your ChatGPTs, that has largely become mainstream. Like most developers are using that. So currently, yeah, AI coding agents are becoming mainstream, but recent surveys show that not all engineers are using them. But with the adoption of autocomplete tools, we do expect that the AI coding agents will be widely adopted within about a year, considering how fast things are moving. So we can reasonably assume that most software developers will be using AI coding agents. So the question we want to answer is, what will a typical engineer's day look like in 2026? Let's give a brief overview of what's been going on in the AI landscape, right? So 2022, so that's 3 years ago, right? Um, GitHub Copilot launched. There was some early developer experimentation. People were talking about it. 2023, a lot more talk, a lot more developer usage. And then by 2025, it basically, the code completion has become mainstream. Your GitHub Copilot plugin for your VS Code or other IDE, pretty much everyone was using it. People were asking ChatGPT questions about how to write your code. They were basically copy and pasting code from ChatGPT to their code environment. So we're today in 2025. The code generation is built in, right? It can generate a lot more code. You've got some AI debugging tools that can help. And we are starting to use AI agents, AI coding agents. AI coding agents mean you tell an agent a task, it'll write the code, create files, it'll run tests, maybe it'll do other tasks like connect to your development server, deploy the code in your developer server, even maybe look at your UI, test out your UI. So a lot more capability than just simple code generation, which is mainstream right now. So we're going into 2026 next year. So, looking at the trends for code generation, we think AI agents will be widely adopted. Testing, automated testing. We think that's a good area. And then AI code review assistants, they are being used right now. Our company fleet just started using one, so I believe they'll become more adopted next year. And then in the future, well, we can speculate, right? That AI will be kind of natively built into a workflow, basically more integration with AI. To a certain degree, you can see that with, say, the Cloud Code, right? The Anthropic AI agent, right? You run it in your terminal, but not only do you use it for code generation, right? You also use it as a chatbot. So basically, perhaps a situation like this where there's just one panel for all your interaction with AI without having these disparate AI tools. Anything we can speculate about that. Maybe you can have multiple agents, right? That's an area, because right now agents do take a little bit of time. So it'd be nice to see if a coding agent could be an orchestrator. You tell it to do one thing, and then while it's doing one thing, you can tell it to do something else, and it can do things in parallel on the same code base without interfering with each other. For example, maybe I want it to make a code change, but at the same time update a related or maybe an unrelated document in another part of the code base. Or maybe from one screen I wanted to work on the back end and on the front end, but do those in parallel. Okay, so let's walk through the software development lifecycle. And basically we'll walk through each stage of the lifecycle and understand kind of what's going on right now and where AI coding agents can be used. And we will specifically focus on AI coding agents, right? Because the question we want to ask is, are they going to replace software developers? How are they going to make our work different in the next year? So high level, the software development lifecycle, requirements gathering, then design, then implementation, testing, deployment, and maintenance, right? So six phases. Let's start with requirements gathering. And I'm combining planning and requirements analysis into this one requirements gathering phase, because I'm assuming we're using kind of a fast-paced, agile, iterative process. So in this phase, we need to figure out why we're adding a feature and what at a high level the feature is. So generally, we have two major sources of product features. The first one is kind of a strategic feature that will open up new sources of revenue for us. The second is a customer request, which could be an existing customer or maybe a prospect that needs this feature before they sign. So we must build those to basically keep our customers happy. And a single feature could be both a strategic feature and a customer request. So we need to understand like what value this feature is gonna bring. And the best way to do that is to actually talk to the customer, like what issues are they trying to solve. If we can't talk to the customer, we could do some market analysis. Maybe if we're building a new product, we can see what features our competition has that are similar. And for all this kind of market research, people have been using ChatGPT, kind of aggregating and explaining this type of information. So ChatGPT has made this type of market research more efficient. Much like in the olden days, Google made research in general more efficient, right? You used to have to go to the library to write a research paper, and then no one went to the library anymore because everyone just used Google. Right, so this is not a new AI use case, I'm just pointing it out. So what about AI coding agents? How can they help here? Well, they have not very much to add in this phase at this point. There may be some use cases, because maybe you need to like scrape some data or fetch something, so you could like use them to write like one-off tools, one-off scripts, just to help you market research. Let's go on to the next phase, design. So here we get into the details of what we're building, right? We specify UI requirements, API changes, integration with other services, and a bunch of other things. So what happens in design, and perhaps to a certain degree happens in the previous phase, requirements gathering, is maybe you have a spike story or you have to build a proof of concept. This doesn't happen all the time, but occasionally for bigger features. So spike story is an agile user story to research some kind of technical question or some kind of unknown. It's used to uncover things like technical feasibility. For example, can we use a TPM to sign HTTP messages? Or in the implementation approach, whether we should use webhooks polling, something else. Integration behavior, like figuring out how exactly this third-party API works, how does it handle errors, pagination, can it even do what we want it to do? Tool or library evaluation, perhaps you need some functionality that's missing and you need to evaluate several third-party solutions. Or just general unknown complexities or risk. Like there's just a bunch of stuff here. It feels like if we don't quite understand what we need to implement, so let's just do a POC just to run through the happy path, just to find out all the unknowns. All right, so in the Spike story or POC, we often need to write some quick throwaway code, and we're not as concerned about other architectural considerations such as maintainability. And this is where AI coding agents can help. In theory, the agent could create a whole POC, right? And the software developer just needs like a cursory review just to make sure it's reasonable. Of course, this is an extreme case, but maybe it'll become more prevalent. But in most cases, your Spike story or POC is going to be kind of a mix of coding, reviewing technical documentation, like reading the features of libraries, etc., searching the web, and of course, using ChatGPT to get clarification on things. So, AI coding agent will help with Spike stories and POC, right? Because we can finish these faster. In many cases, this type of work is time boxed. So if you time box and you're able to get more done with your AI coding agent, the hope is the end result should be higher quality. So you should have a better result, leading to better future design decisions. All right, so we did our Spike story or POC. Now we actually need to finish the design, right? We need to provide all the technical specifications required so that in Agile we can estimate and then implement this story. So this includes UI, configuration, authentication, monitoring, logging, error handling, scalability, performance, internationalization, and a bunch of other stuff. So here, this part kind of requires thought. We can't farm it off to AI or an AI agent. All they can do is kind of provide a boilerplate. Maybe some things like monitoring and logging are largely standard across our features. So we can use AI just to generate that boilerplate, but we still need to consciously think about these things and of course review the design docs. All right, so at this point we did our design, we did our estimation. Let's move on to the third phase, implementation. This is where we code. So the question is, can an AI agent do all of this? Well, first of all, we may not be able to take the design from the previous phase and just feed it into our agent, because maybe a product manager or another engineer may have done the design and maybe it lacks enough details for the actual implementation. So before we feed it into our agent, we have to kind of get into more specifics about kind of what the software is going to look like. So we're talking about things like function names, also constant enum names, file and package structure, like are you creating new libraries, new packages, what's going on, and then various other things like error handling strategies. How are you going to handle error? Is it the standard way, or is this like some kind of weird integration you have to do to pipe your errors into your telemetry tool? Then we have to decide which parts of our code are going to have interfaces, right? Interfaces are mainly useful to simplify testing, so that way we can mock out the interface. So you kind of have to think how you're going to break up this logic, and of course security considerations. We all know AI coding agents at this point are not great with security considerations, since there's a lot of code out there that has poor security hygiene. Yes, AI coding agent could come up with some of these on its own, but even if we do a first pass, maybe we ask it to write a plan for us, how it's going to do these things, we still need to consciously consider each one of these to make sure that our code base is maintainable, testable, scalable, and handles corner cases. All right, so once we understand these details, maybe we wrote them down, then we can write a prompt to our AI coding agent and let it do its work. So in our experience, AI coding agents are not very fast. We tell it to do a chunk of work, it completes it in several minutes. Then we come back, kind of do a brief review of what it did. Maybe sometimes if we're watching it do its work, we would say, oh wait, what are you doing here? This is not, you're modifying the wrong files. Sometimes that happens. You ask it to modify a file, it modifies the wrong file because that file had like the same function name. So sometimes, we have to interrupt it. Anyway, if it finished, we come back to the corrections. And corrections are things like, hey, you didn't use the correct coding standard. This is how it should be. Maybe you wrote some code that we don't need because we know this code is in reality unreachable. You've got some duplicated code. You're using some poor names for functions and variables, things like that. If we let the AI agent do a bigger chunk of work, like something that takes 30 or more minutes, in our experience, there's a greater chance that it'll go off the rails, right? We can't just sit there and watch it the whole time. Well, maybe we can, but it's kind of tedious and kind of hard. For example, in our case, we asked it to do some work. It tried to use a third-party library, the right library to use, but like it couldn't figure out how to make it work. So then it just decided on its own that it's gonna just implement its own version of that library, which ended up not working. All right, so let's give a brief overview of what we talked about, right? We write a prompt. We typically wait a few minutes. We kind of review the code. By review, it's like a cursory review, just make sure everything's reasonable at this point. We go back and make some changes. Another thing I want to point out about the changes is sometimes like it codes it up, and then as we're looking at the code, we find more issues. We're like, well, it'd be nice if this code wasn't its own package, or maybe, this doesn't feel right, feels kind of hard to maintain. So just having the code out there may make us think, this could be done differently. So, it does help us iterate, right? Because AI coding agent can pump out so much code. It feels like if we're thoughtful about the code, it's possible with this loop to end up with higher quality code than we can write ourselves, or at least we can write ourselves in a limited amount of time. So we go through this loop. After the code is acceptable, we ourselves look at all the code, and we have to pay attention to details because it's all generated, right? We cannot actually trust anything. Then we ask another AI agent to review the code. It could be just another agent, or it could be a AI review tool. And only then do we put it up for actual review, where a peer of ours, another engineer, would review it, and merge it and ready for Q&A. Of course, it's a simplified flow. It's possible that we're going to have, this feature may have like multiple PRs, but this is a simplified diagram. All right. So let's talk about multitasking. So I've heard on podcasts some developers report that they're using multiple agents to work on numerous projects simultaneously. At high level, we think this is not practical, right? Behavioral science research show that it takes a human about 15 minutes to entirely switch between different tasks because you have to kind of reload and recall all of the context associated with the other task into your brain. So if we're using multiple AI agents to work on multiple projects, that means we're kind of switching between tasks every 5 to 10 minutes. So in the result, we're never actually deeply engaged with any one of these tasks. And that's likely going to lead to lower quality software. Now, perhaps two coding agents can work on kind of two tasks for the same feature, but these two tasks must largely be independent, which is more of an exception than the norm. I have been experimenting with trying to work in parallel. I feel like some cases are useful. So for example, I would have AI coding agent continue working. And at the same time, I would have this draft PR up that I'd be checking in, and I would see that there's some test failed. So like in parallel, I would try to look at that test. So I've been trying to experiment with some multitasking. So I think there is some reasonable level of multitasking that can be done as long as it's kind of all related to the same issue, so that you're not having to do a full context switch. So we're working on an enterprise code base, and a lot of software development work involves hooking up this feature into the existing code base. For example, you need to actually create this new object that you've just created. We have to do dependency injection, and these things often take just a few lines of code, but we need to figure out where we're going to do that. And although AI coding agents could do these integrations, it's often just as fast and more reliable to manually code up these kind of smaller snippets. So in this case, when you do an integration, AI agent, arguable. All right, let's talk about full stack development, right? One benefit of AI coding agents is they can help you write in a programming language that you're unfamiliar with, because you'll do a high-level description and the agent will do kind of the brunt work, getting the syntax hopefully right, and then you just have to review to make sure the code looks reasonable. So that means you don't need to know the full syntax yourself. You just have to kind of recognize it when you see it. It's kind of a difference between doing a multiple choice quiz, which is a lot easier than doing a free-form quiz where you actually have to write out the answer. So what this means? So this means software developers can easily expand beyond what their main focus is into either other languages or other parts of the code base with the help of AI coding agents. So this is great, right? From a software development perspective, now a single feature could be completely assigned to a single developer instead of having it partitioned across backend and front end, service and client, etc. So a single developer is more likely to just take a whole feature that's across multiple languages, even multiple code bases. So in summary, for the implementation phase, AI coding agents can significantly help speed up this phase. But note, their effectiveness varies by task. Agents often struggle with complex or niche designs and unfamiliar contexts. Now, phase number 4, testing. So there's two main testing areas, right? We have automated tests, including unit and integration tests, and then manual tests. So let's talk about automated tests. That has been actually a large, maybe even a primary use case for generative AI, right, over the past couple of years. That was the main use case. You already have the code. You ask your GitHub Copilot to write you the test for it. So given the detailed instructions regarding the scenarios, the AI code agent should be able to write the test, run the test, and then fix any issues. Of course, the developer will still need to review and adjust the test. Here are some examples of problems that we've seen in tests. Not following project standards, right? AI coding agent relies on like general standards across the industry, so it might not exactly be following your standards, like not using the right helper methods, not using the right HTTP client, not using the right assert methods. Also, sometimes AI generates kind of wordy and hard to maintain tests. So I often need to tell it to try to follow a table test approach or to use subtests. We've also seen it create duplicated tests, like it will create a test that's actually the case is already tested somewhere else, maybe in a different file or maybe even in the same file, right? Using numbers in variables instead of descriptive names, that's just a nitpick, but it is a maintainability thing, right? A human may need to look at the test if it starts failing, right? So instead of RSP1, error 2, we wanted to use like actual more descriptive names. And in some cases, we've seen it actually not test anything, right? Maybe it tries to run the test keeps failing, and then it just like ends up doing something crazy like hard coding test value in the actual actual implementation, which is silly, right? So it could just do something crazy that, you know, skipping tests or, you know, other stuff. You got to watch out for that. So let's talk about corner cases. So AI agent could come up with some corner cases, but we cannot rely on it to achieve full functional correctness. AI agent can see the implementation, right? And it often bases its tests on what's been implemented. But it does not actually understand what were the intended requirements, what the feature actually does, and hence it doesn't actually understand what needs to be tested. So it's up to the human to discover these corner cases, to think about all the corner cases. So AI agent is writing the test, and the human's responsibility is to figure out what needs to be tested. All right, automated tests. And now let's move on to manual tests. So before handing over your implementation to the QA team, the software developer should review the test plan, maybe write the test plan, and actually perform the test plan themselves. And any issues you find are clearly candidates for additional automated tests. So there's no AI agent today that can replace manual testing. But there are some tools that try to help, right? There is some tools that try to convert natural language to test steps. There's some tools that try to compare like your UI to see if there's any regressions. There's tools to help with accessibility testing. There are tools that try to kind of how to update tests if they see that UI changes and the test starts failing. It tries to fix the test, right? It's called auto-healing tests. So overall, when we look at the testing phase, AI coding agents provide a lot of help with creating and fixing automated tests, but not so much with manual testing. All right, we're almost done. Let's go to the fifth phase, deployment. Before deploying the app to the customers, like we need to do a release readiness check. Things like have all the features we committed to have been implemented. Has the testing and QA completed? Have security checks passed? Has, you know, performance load testing been completed? And perhaps a bunch of others. And then we deploy our app, and after deployment, we should conduct some smoke tests and health checks to make sure the deployment actually worked. We also need to communicate, right? We need to have demos of the features, guides for the features, frequently asked questions, release notes, change logs. You know, we need some communication, some documentation. Generative AI is being used right now to generate some of this communication content. But as far as specifically AI coding agents, you know, they don't really provide much value in the deployment phase. All right, and the last phase is maintenance. So we're talking about answering questions, internal customer questions about the feature, responding to alerts and incidents, maybe where you need to investigate high CPU usage, maybe there's like a background job that failed we need to fix. And of course we have bugs. Bugs come in, we want to reproduce them, figuring out what's wrong and to fix them. So like AI in general has been good at kind of searching your own code base and documentation, right? We have the RAG concept where like Cursor uses RAG, other tools such as SourceGraph Cody uses RAG. They kind of build a vector database over your code base and documentation, and then marry that with an AI agent to kind of provide like detailed answers when you ask it about your own code base, like how does this feature work? You know, what happens if we set this to 0? Will it still work? As far as kind of alerts incidents, this is a great area to watch, right? Some people are developing tools that try to close that loop between kind of monitoring production and then trying to fix production issues, trying to close that loop with an AI agent. Bugs, reproducing bugs is still very much a manual process, right? Your customer tells you something, maybe maybe it's obvious, like maybe you can feed that, like a customer reported this, what's the issue? That's a good thing to try. Like if you're not really familiar with what's going on, maybe your AI could point it out. But traditionally, we still kind of need to manually make sure we can reproduce the bugs, so that way once we fix it, we can follow the same steps and be confident that we actually fixed the bug. So as far as fixing the bugs, well, fixing the bugs is effectively an implementation task. So AI coding agents can help mainly with a unit test, right? We typically want to create a test that kind of surfaces the bug, and then we fix it, and then the unit test will pass. But the bug fixes themselves, typically they're small in nature. Like they could be large, but a typical bug fix we see is kind of small, like a few lines. And most of the actual software engineer's time is spent figuring out where it is, reproducing it, like understanding what it is and how to best fix it. All right, let's move on to the summary and conclusions. All right, so we talked about the requirements phase, AI agent impact here, kind of pretty low. Design phase, good help with spike stories and POCs, so maybe low to medium impact. Implementation, that's where the coding happens, high impact. A lot of benefits seen here, especially with AI agents improving. Automated testing, also high, right? This exists already. A lot of people are using AI for creating the tests, so that will continue to have a high impact. Manual testing, a low impact. Deployment, also low impact. Maintenance, low to medium, I would say. It's just good at maybe kind of help you fix a bug, largely providing the test. There we go. So one more thing before I go into the conclusion, we have to mention some risks. Right, AI coding agents offer clear benefits, right? Speed up, but there's some risks that we do have to mention, right? And people are concerned about these. First one is kind of shallow code understanding. If engineers are relying on agents, they may not like fully understand the generated code. This erodes accountability, right? If someone else asks about the code you wrote, you're like, it wasn't actually me, it was the computer that wrote it. It also, if you don't understand the code, then this is gonna lead to slower debug when an issue comes up. inconsistent quality. Oftentimes, agent-generated code can be verbose, redundant, or kind of some, annoyingly incorrect, subtly incorrect. So this is why I mentioned that when you're reviewing code, you actually have to make more of an effort to review agent-generated code than you would to review another human's code. Developer de-skilling, right? If developers are relying on agents, what about like hands-on coding practice? They're going to have less hands-on coding practice. And this is particularly insidious for kind of junior engineers who are still kind of developing their intuition. I don't have any specific suggestions just off the top of my head. It feels like there needs to be like almost like, like you practice martial arts or practice basketball. You need to have like a coding practice time just to make sure you get your fundamentals under your belt. Security and compliance is another risk. So agents could unknowingly introduce vulnerabilities or use some unsafe patterns because they're just going off what's out there in the world, especially when integrating with third-party APIs or handling sensitive data. So AI agents can amplify your output, but they need discipline and oversight, right? Once again, teams and engineers must treat agent-generated code with greater rigor than human-written code. So, conclusion. Will AI coding agents replace software developers? Well, recent studies suggest that current AI tools improve productivity from 10 to 20%, like Google study, JP Morgan, Atlassian. Some studies actually said that AI slows down, some experienced developers. But let's just roughly say currently 10 to 20% productivity improvement. So when we're looking out a year and ahead, when like most engineers are using AI coding agents, right? Is this productivity going to jump even further, right? Will one engineer be able to do the work of a whole team? Well, we just looked at the software development process and we saw that most significant gains from AI coding agents are in the implementation and automating testing phase, so the actual coding phase. But engineers do a lot more than coding, right? If you just look at the phases, like help with the requirements, help with the design, you still need to do manual testing, you need to deploy, answer questions, root cause, bugs and fixes. And besides development, engineers have other tasks, right? We have attending and preparing for meetings, including planning retros, one-on-ones. We are mentoring, teaching, or learning ourselves, juggling random tasks. We are recruiting, interviewing, evaluating candidates. We are writing internal documentations, architectural decision records, requests for comments. We may be doing some developer advocacy, blogging, community engagement. We may need to be traveling, conferences, offsites, customer visits. And then we're working on the development environments, right? We're working on developer experience, improving our own tooling, automation, just to make work in general better. So the consensus from studies, right, from not today, but from general consensus from studies in the last 10 years or so, report that software engineers spend only about 30% of the time writing code. All right, so let's assume AI agents completely automate all coding tasks. So your 30% is now freed up. So that means you can do approximately 1.4 times the work you are doing now, right? If you don't have to do that 30% of coding. Now, maybe that was the best part of your work, coding. So maybe this is definitely not the same job you maybe signed up for. But the reality is that's where we're heading. Engineers need to be kind of more higher level, um, and not as much in the weeds of the actual code. All right, so 1.4 times the work. So in other words, 7 people can now do the work of 10 people. This is pretty far from the claim that AI will replace all software engineers, right? We're looking at the current trends, we are going to get more efficient, and we are going to see noticeable impact on software developer productivity. However, developers' work is complex and varied, and AI can only provide efficiency improvements and not wholesale replacement. So in conclusion, AI coding agents won't replace developers, but developers who know how to use these AI coding agents could replace those who don't. That's it for today.